negative 5.8 plus or minus 9.3-ish, right? So the short period mode for that RC aircraft that we did was this. What was the natural frequency? How do you find it? So like 6 squared plus 10 squared. So that's 100 plus 36. What's the square root of 136? Like 12? Sure. Why not? We don't have a calculator on the board here. So let's say it's 12 radians per second. Okay, what does that tell us? What if I asked you to give me the period? How would you find the period? You'd probably have to find the frequency first. What's frequency equal to? 2 pi over omega n, right? So I would do 6.28 over 12. So that's about what? A half? So 1/2 hertz? Your ishing is on point, right? Okay, so then how would I get period? Period is equal to 1 over s. So then t would be what? 1 over 1/2?
2 seconds.
2 seconds. Okay. So that means the period of my oscillation is 2 seconds. So it means in 2 seconds my airplane is going to go from here to here to back. All right? So it's like 1/1000, 2/1000, and then done. Right? So it's a very quick oscillation about the pitch axis. So it's like whoop, and then it's done. So it's like it's almost, you blink once or twice and it's over. Right? What's the second longitudinal mode? Long period. What's the other name for it? Phugoid. What are the prominent states of phugoid? X and Z. There are 2 other states that are also prominent in this one. Theta and U. Okay? Does this one oscillate as well? This is an oscillatory mode. So what were the eigenvalues for this one? Anybody remember? I don't actually know if that's right, but I think that's close. Okay? So how do we know it oscillates just by this eigenvalue? It's imaginary. Okay, so if I told you to hold this airplane and describe to me the longitudinal motion, what would you do? Go up and down like this?
Yep.
And then come back down?
Mm-hmm.
Why is it doing that? Why does the airplane do that? How would you initiate the phugoid?
Hit the elevator.
Elevator is going to activate elevator will activate short period.
Maybe thrust.
Exactly. Thrust. How many longitudinal controls do you have?
2.
Longitudinal, 2. What are they? Thrust and elevator. So elevator activates your short period. Thrust will activate your phugoid. So if I'm flying in trim and I hit thrust and I start to fly faster, what's going to happen? You're going to get more lift and it'll start to climb. Are you going to climb forever? What's going to happen? You're going to start to slow down, you're going to start to pitch forward, and then you're going to start to come down. Then what's going to happen? You're going to speed up. So when you speed up, what's going to happen? You get more lift, and you're going to come back up. Why is this oscillation so long? Why does it take forever to dampen out? What's the only thing slowing you down? Drag. And are you at minimum drag more than likely? If you're flying in trim, you're probably at minimum drag. So you have very, very little drag that's slowing you down. What's slowing you down with short period? When you do this, what's going to slow that oscillation down? The air hitting the horizontal tail. So basically, you have CMQ slows you down. And why did I pick CMQ? What is CMQ?
Pitch moment due to
Pitch moment due to
the angular velocity and that direction.
in the pitch axis,
Yeah.
which is called the pitch rate. So it's the pitch moment due to the pitch rate. So it's the damping coefficient, the damping aerodynamic coefficient due to pitching about the pitch axis. And so if I pitch about the pitch axis, right, if I do this, or rotate about the pitch axis, I'm going to get extra inflow on the tail, and that's going to slow me down. That term, CMQ, is bigger than the term that's slowing me down here, which is just CD naught. Right? This is like 0.08 or 0.03, and this is like negative 8.5 or something like that. You have a much bigger damping term about the pitch axis than you do about the forward drag. And you can tell, right? What's the natural frequency of your long period mode? Yeah, so what is that, 0.009 plus 0.36, square root of that? I don't know what that is. Well, if this is 0.6 and this is 0.03, what's that? 0.6, it's probably 0.6 anyway, because if you draw a right triangle, right? That's what you're doing, right? You're doing this Pythagorean theorem. So let's just say this is like about 0.6 radians per second-ish. Okay? So then what would your frequency be? 2 pi divided by that? Omega n equals 2 pi f, right? Oh, that's why. We did it backwards. Unbelievable. Okay, let's all backtrack, scratch that. Omega n is equal to 2 pi f, isn't it? We just did the math in our heads wrong. We all did it collectively together. Okay? So then this is actually, so f is actually omega n over 2 pi. Okay, so this is actually 12 over 6.28. So that means this is actually 2 hertz. And so this is actually 1/2 a second. Okay. All right, it doesn't change much. It's still short. Okay, so instead of it being 1/1000, 2/1000 done, it's more like 1/2 a second, like blump. So you're halfway through your blink and you're done, and the oscillation's over. So it's very, very short. Okay, so this one, on the other hand, f is 2 pi is 0.6 over 2 pi, which is like 1/6. What's 1/6? What is that, like 0.1? Let's do this. This is like 6 over 10 times 6, so it's like a 10. How about that, right? 0.6 is 6 over 10, so this is 1/10. So 0.1. Let's do that. All right, so it's 0.1 hertz, and so my period is what? 1 divided by that? So what is that? 10 seconds? Did I do that right? I feel like we're doing math like terrible right now.
Mm-hmm.
Should somebody pull out a calculator?
1/6 is 0.16.
So what's 1 divided by 0.16? I thought it was like 100 seconds.
6.25.
Something's wrong here. Is this really the eigenvalue? What did Rockwell do? Just shrug his shoulders?
He said probably not.
Probably not. Should we pull up MATLAB? That's right. Yeah, it's like square root 0.03 squared plus 0.6 squared. Yeah, so you get your natural frequency 0.6. So then you do 2 times pi divided by that. So you get 10. No, not 2 pi divided by that. 0.6 divided by 2 times pi. You get 0.09, and then 1 divided by that is 10 seconds. Huh. So 6.25 is almost right. Why did we get 100 last time? Didn't I do this problem before? And we got like, Okay, since class is almost over, we'll come back to that in a second. The last thing on here is longitudinal control. Okay, so how do you control short period mode? The elevator. How do you control the Fugler mode? Thrust. Okay, and so that's pretty much it. And so what can you do with those things if you apply feedback, like if you apply gain to it? We did this last class. You can kind of plug in a gain, and then what happens to your mode? Yeah, it increases or decreases the amount of damping you have in the system, right? Cool? You want negative gain, right? Okay. I wonder if we just did the math wrong last time? Does anybody have their notes from where I computed like 100 seconds last time? You didn't write it down? Your dog ate it or something. Your two cats got together. They ate it. And they ate it. All right, does anybody have any questions about overall concepts from Colin? You can watch the video after this.
Bonus points for people who are here.
Bonus points? So, did I write these equations down wrong? Omega is 2 pi f, is that right? Okay. Because that's radians per second, right? Radians per second. And then omega n is sigma squared plus omega squared, right? That's the norm of the eigenvalue. And so f is omega n divided by 2 pi. And I don't know why I got 100 last time. Maybe I fat fingered a number or something like that.
I got 10.
Yeah, when I did it on the computer, I got 10. But we got like 100 seconds last time. That's why I'm confused.
Oh, we had something else.
Then, well, if anybody can find the notes, I'm going to go ahead and shut off the video. Good luck.